All right, guys, we'll get started here. Looks like it's right at 10 o'clock. My name is Jordan Weiss. I'm a sales engineer here at Long. I want to thank everybody for joining us this week for the weekly Long coffee break with the weather and all. I appreciate it. Looks like we have a pretty good showing here. Today, we're going to go over indirect evaporative coolers with Sealy International. We've got Steve Clark here today, and he's going to put on a little presentation for you guys. So without further ado, I will shoot this over to Steve and we will go from here. Let me get this.
Okay, thanks, Jordan. And thanks for having me on today. So wait for the slides to get started here. Today, my name is Steve Clark. I'm a applications engineer with Sealy International here in Denver. Today, I'm going to talk about indirect evaporative cooling, or going below the wet bulb with our Climate Wizard units. So we are an Australian-based company. Our main manufacturing is in Australia. We have about 500 people over there. We also have sales offices in Denver, Phoenix, Arizona, in the UK, France, Italy, and South Africa. So we are truly an international company. We make our smaller coolers, Climate Wizard coolers, are made here in Denver. Here's a little bit of history of the company. Started out in 1972 with the first all-plastic evaporative cooler in the industry. In 2006, we came out with a Climate Wizard unit, indirect evaporative cooling. And in 2015, Sealy International acquired Colorado. So I started out with Colorado. We're basically the same Colorado group, but we're wholly owned by Sealy International. Our headquarters, like I said, is in South Australia. That's where we have our main research and development group, engineering, product engineering. We also have $1 million test lab where we test not just our products, but our competitors' products. And that's how we come up with the performance information that we publish. Here's just a slide, kind of our NASCAR slide of the different applications, types of applications: industrial manufacturing, data centers, healthcare, restaurants. Do a lot of things with our indirect evaporative coolers. And we do this internationally. This is a slide just kind of comparing the Climate Wizard performance with vapor compression systems. As the ambient temperature goes higher, you all know this, that the vapor compression, refrigerated air conditioning uses more energy. Our units actually get more efficient as the outdoor temperature gets hotter. Now, the next thing, the key thing to understand our units is to talk about psychrometrics. If we look at an outdoor air condition of 100 degrees, 70 degrees wet bulb, direct evaporative coolers or adiabatic cooling goes up this line, and you're really not doing any work on the air. Our Climate Wizard units are indirect evaporative cooling and start from that 170 outdoor design condition and go to the left. So this is purely sensible cooling and achieving energy savings up to 80 or 90%. So you might ask, well, how do we do that? Well, we have a plate, a heat exchanger it's a cross flow heat exchanger where we take the outdoor ambient air, run it through this heat exchanger, which consists of wet and dry sheets. And we cool the air down. We put water in at the top, and that water flows through the wet sheets from the top to the bottom. And then we put we have a damper that puts a back pressure on the backside of the heat exchanger that forces some of this cool air back through, which cools the hot air down. And then the orange arrows are the exhaust air that go out of the unit. Here's a picture of our heat exchanger core, and you can see the hot air comes in through the face of the heat exchanger. We put water in at the top, and then we have a conditioned air coming out the back side. There's some dimensions. It's roughly 24 inches deep, 24 inches wide, and 32 inches high. And then the exhaust air comes out the top. So this will cool below the wet bulb temperature. Here's a cutaway of our unit. It shows the supply fan, the outdoor air coming in. This is a blow-through type design. So we're pressurizing the face of our indirect evaporative cooling module. We have the conditioned air coming out to the left. This some of our units, we call our super cool units, have a direct evaporative pad for slightly lower temperatures. So that's an option in our units. And then the exhaust air goes out through the top. If we look at our products, our kind of our flagship model is the CW-H15. We actually make this in Denver. This is about 2,300 CFM, about 7 tons of cooling. And then we make a larger unit called the CW80. This will do 13,500 CFM. These larger units are about the size of a shipping container. Those are all made in Australia. And notice the EERs, 40, 46, 48, quite impressive for evaporative cooling, direct evaporative cooling, or indirect, I should say. Here's our line of the super cool units. You can't tell a difference between on the outside between this is a CW-H15. This is a S unit. We have the S and the S plus. This has a direct evaporative pad in the housing on the left side of the cooler. And then we also make the CW80 in an S unit. Now these are designed for commercial and industrial applications. But just this year, we're introducing a residential model of this called the CW3 that's about 3,000 CFM. That's going to be rolling out late spring, early summer. So we're pretty excited about that. Now, if we consider how you would apply these units, if we look at standalone cooling, you can see on the left, we have our Climate Wizard unit pulling in the outdoor air, cooling it down to the wet bulb or below the wet bulb, and then providing it in this ductwork in the space. And this is basically 100% makeup air unit, cooling unit. So you have to exhaust the warm air out through the top of the building. So that's a standalone evaporative cooling. If we look at pre-cooling, here's where we're using the Climate Wizard unit to cool that outdoor air, the ventilation air, to a package unit. So this could be an RTU or an air handler. Since we're doing sensible cooling, we're not adding any latent load to this package unit. And this package unit can also have some heat. So in the wintertime, you can use that for heating and then cooling in the summertime. Another variation is the supplemental cooling. Here we show the Climate Wizard unit with the duct heater here to provide heating in the wintertime, cooling in the summertime. Then we have another unit also providing some cool air to the space, and even on this system, a VRF. So you can combine this, our units, Climate Wizard units, with a variety of refrigerated conditions. So if we look at some applications, here's a good one we did in Denver. This is at Regis Jesuit High School, the girls' gym in Aurora. Previously, they had no air conditioning for the gym. All they had is a heating and ventilation unit. They put a CW80 unit. It was installed in July of 2019. Here's a picture on the right. You can see it on the roof. So this is providing conditioned air. I tested this unit in the field shortly after it started up and calculated an EER of 58. Now, the next slide, I'll show you a little bit of the psychrometrics. On that day, we were at 95.62. We were cooling the air down to 60 degrees, doing sensible cooling. And this unit is actually a super cool unit, so it has a direct evaporative pad. But the air was cold enough, they didn't even need to turn on that direct evaporative pad, but they could have gotten a few more degrees out of the unit if they wanted to. This is an application that a lot of you might recognize, Grundfos, the manufacturer of hydronic pumps. They put 10 of our CW80 units on their manufacturing facility in Fresno about 8 years ago to cool the space. They've been really happy with those units. Here's an application at a car dealership, a Toyota and Chevy auto dealership outside of Sacramento, where they used 51 of our CW H15 units, along with solar panels, a white roof. Combined, all of this reduced their energy consumption by about 87%. So that was quite a successful project. We do a lot of work, like I said, internationally. Our Australian applications group, sales group, did a project for Amazon where they installed 7 of our CW80S units on a warehouse for Amazon. This is for in Western Australia. That's a fairly recent project, just about a year ago on that one. So some of the things that we can offer you design engineers is we have a spreadsheet calculator that where you can put in the elevation, the design conditions, the wet bulb and dry bulb, and it will give you the leaving air temperature, dry bulb and wet bulb for all of our units, the H15, the CW80, and even our residential unit. Another piece of software we offer is an annual sizing calculator that'll do an 8760 annual analysis, and something we developed because the current modeling software will not model direct or indirect evaporative cooling that will go below the wet bulb temperature. So this is something we had to develop on our own, and we make this free to anybody that wants to use it. So it's a nice tool. And lastly, I just want to wrap up with, we also make direct evaporative coolers called the Breeze Air units. These are all plastic units, guaranteed for 25 years, the housing is. And then we also make condenser pre-cooling systems called dual cool and coil cool for existing RTUs and air handlers. So that's all I had for today. I want to thank you for allowing me to present. And if you have any questions, you can ask Jordan and he can forward them on to me. Thanks.
Cool. Thanks, Steve. I really appreciate it. Again, I want to thank everybody for joining us this week, for making it out with the weather and all. This is a product show for you guys to educate you guys on what all you guys need and what we can offer. Please reach out to your Long sales engineer if you have any questions. And thank you again, Steve. And please join us next week whenever Leroy Willow goes over AQC ductwork. Should be a pretty exciting presentation. But until then, take care of each other and be careful. Thanks.